Just wanted to say welcome to all of you, getting out of the rain. I think it's still raining out there. And I am Melody Brown-Berkins. I'm the director of the Institute of Arctic Studies here in the John Sloan Dickey Center for International Understanding. And it is very exciting to have Dr. Eduard Ariza Solé as our guest tonight. He is an associate professor of geography at the Universitat Autònoma de Barcelona. I say that kind of with a French accent, which is probably not correct, and the director of its Arctic Research Center. I met Eduard through mutual Arctic colleagues that we share in Iceland. Dr. Niels Einarsson is the director of the Stephenson Arctic Institute over there in Akureyri. And in fact, it was the Stephenson Arctic Institute and Dartmouth Institute of Arctic Studies who worked together to support the Universitat Autònoma de Barcelona in setting up the Arctic Research Center. I think it was in 2017. Was that correct? 2017 or 2018. And when Eduard became its director, he reached out to me and the Stephenson Arctic Institute to have one of the first Arctic conferences that we were able to have after the COVID pandemic eased. It didn't end, but it eased. And we met to discuss really important issues that were facing the Arctic Council, even though it was paused due to geopolitics. But we looked at gender equality in the Arctic, and we heard, well, I guess it wasn't paused then, was it yet? But we talked about gender equality in the Arctic, and we heard from the European Union's special envoy to the Arctic at that meeting. So I was then honored to be able to host Eduard here at Dartmouth for the past year as a distinguished visiting scholar in the Institute of Arctic Studies. He's been meeting with faculty and with students across disciplines, studying how institutes and centers function at Dartmouth, and both developing and submitting competitive grant proposals for both his Arctic and his global coastal work to funding organizations across the European Union, and we're hopeful that maybe there's some Dartmouth connections in that as well. His research combines human geography and environmental science in the study of complex socio-ecological systems in coastal areas, and it draws from both complexity theory and post-normal science frameworks to study and inform the governance of the land-sea continuum. And I'm not at all embarrassed to admit that I needed to Google most of the last sentence I just said when I was looking at hosting Eduard. But I learned quickly that these were the names of the kind of research that I knew was not only cutting edge, but also in high demand across the world. This is truly, what he is practicing and will tell us about tonight, is truly engaged, co-produced research that is done with and for communities, working to bridge diverse knowledge systems, foster decision-making, and inform policies while recognizing, this is interesting, that facts are uncertain. Values may be in dispute, stakes are very high, and decisions are urgently needed. In short, this is the applied of applied research. It is studying what many believe is too complex to study, but it is exactly the kind of research and the studies of our science systems that we need if we hope to inform and support a future of more sustainable development across the planet. So tonight, he will give us a talk that tells us how these methodologies and approaches must evolve to consider the myriad social, economic, environmental, political, and human rights complexities of managing our environmental systems, looking at our environmental challenges, and including all of those issues that we are facing with climate change. He often asks who is at the table, who is developing these research questions, who is making the decisions for how we shape our research. And by including diverse knowledge systems, he knows that we are better able to understand how our research is framed and how we can help communities around the world. With that, I welcome Dr. Eduard Ariza Solé to the podium for his talk, Climate, Inclusivity and Uncertainty, Evolving Science Approaches, a Coastal Study.
Thank you, Melody, for this very, very nice presentation. I'm used to that, but still I feel very well every single time that I have the opportunity to interact with you. And thank you everyone for being here. Today I've been told it's not an easy day to be here, so I will take that as a very important compliment. I'm here, and I'm very happy to be here. It's an honor and a pleasure at the same time to be here with you and to learn from you, which I'm sure it will happen as well when it comes to the moment of the research questions. But other than being that feeling very well, I think that for me it's kind of a duty as well to be here. I'm kind of I know most of you, but I think that I owe you a little bit of a more detailed explanation of who I am and what is that I'm doing and why I'm doing so. I'm going to present, as Melody have said, I'm the director of the Institute of Arctic Studies, or the equivalent, the CERARCTIC in Barcelona, and I'm learning a lot. I'm not embarrassed to say that I'm a newly arrived to the Arctic. So this first slide that you have here, it's a metaphor of my trajectory. I'm transitioning from non-Arctic to the Arctic. What I'm going to present today, because I feel at this moment I feel much more comfortable, and I think that is much more consistent, is the research that I've been doing with my teams in non-Arctic areas, and that I'm now translating to the Arctic. Next time that I'll see you all, and I hope that is very soon, I hope to present the same but applied in the Arctic, or with more Arctic stuff. Anyway, I feel very confident that the work that I'm presenting here is very important for the Arctic as well. It has been developed by a team of fantastic researchers that have been rigorously working conceptually and empirically in the questions that are kind of universal. So that being said, I'm gonna start with the talk. The idea, the point that I want to make today, the main narrative, is the importance of the framing of the research and the assumptions that we make when we do research for socio-ecological systems. And I will mainly try to connect to see what's the role of assumptions in science, and what's the connection between assumptions and value-ladenness, because we are making assumptions, and we are making assumptions for some reasons when we do research, right? So what are the reasons why we are making assumptions and how they affect the product of science? I think this is a very important question. So I'm going to start with trying to make this link: assumptions, value-ladenness, and science. Then I will introduce a framework that I think that connects well the three elements, that is the transformative learning and science framework. After that, I will mention just 3 key works on assumption analysis for socio-ecological systems that I think that are very important, or at least were very inspiring to me. Then it will come the core of the talk, that is the presentation of 3 examples of assumption analysis that my team has worked on. And at the end, finally, I will provide some concluding remarks. So the first thing that I want to pay attention, it's something that it's obvious, but I think it's very important to say the debate. This is what is called the modeling relation, the Rosen modeling relation. It's a proposal from a theoretical biologist, Robert Rosen, that was made in 1985. And it tried to explain the way in which science proceeds. So we have the observed system. Let me see if I can, okay. And then we have some perception here, and from that we start doing science, first encoding information, creating a formal system in which we make inferences between the variables and the elements and the laws that govern the relationships. And then we predict, we do a decoding exercise in which through science we try to predict what will happen, right? So this is pretty much the cycle of the scientific knowledge production. The first point that I want to make here is that in this process, we make assumptions. And what are assumptions? Assumptions are simplifications of reality. We will not be able to do science if we did not simplify. So we need to simplify, and the key point here is how we simplify and what elements we use to make those simplifications. We simplify mainly, well, in the whole cycle, but I want to pay attention to the perception process. What we include in the scientific analysis, what we encode, it's just a selection of the available information, right? So we make what a colleague of mine, Mario Giampietro, called pre-analytical decisions. Before analyzing anything, we are making subjective choices of what we will analyze. So we have some assumptions and what we call, explain later, some value latedness here. We make other assumptions as well, but I would say that this is the most important point. We also make assumptions when we do the model. We use the information and knowledge that is available, but we don't have the quality of the knowledge that we have available is not the same, and it's uneven. So we are using information that may not be of the same quality than the rest of it. So we are making assumptions and we are trying to give coherence to a process, but we should be very conscious of that. Right, so first we make assumptions. Another point has to do with value latedness, right? So the fact that facts and values, as Melody was explaining, are intermingled, that we cannot distinguish facts and values, and that science is value laden is something that has been extensively researched and theorized. We know that from sociology of science. I would say it's the main body of literature that has studied that. That's something that is real. It has been studied mainly in conceptual terms. There are some empirical cases, but I would argue that this connection, this more systematic connection, is needed in between value latedness and assumptions. Another point that I wanted to make here is the fact that when we are studying socio-ecological systems, so human and natural systems that are co-evolving, I think it's very important to consider that as a complex system. So if we have a complex system, understanding a complex system from a unique point of view is not possible, right? It's not epistemologically, is not possible. So we have to understand, and we can use the example of the forest, that we have a system with different dimensions and non-equivalent descriptions of reality. So when we ask the question, what constitutes a good forest, this question is not a scientific question. This is a political question, because we have values in here. What a good forest is for some people is different from what is for other people. If we think of a forest, that the main function of a forest should be maximize biodiversity, we will manage the forest in a certain way. If we think that the main function of a forest is producing products for the communities that live in it, we will manage it in another very different way. If we think that the main function of a forest is carbon sequestration, we will apply other techniques. So what we have to understand here is that when we make a choice of what a good forest is, we are making a political choice. This is not a scientific choice. That does not mean that science cannot help us in this debate. Science can provide evidence for the different positions to be better prepared for a negotiation. But still, we are dealing with a negotiation process. So, in other words, so we have here the fundamentals of how socio-ecological research or climate change research is essentially value-laden. Okay, now I want to move because I think that we should better establish the connection between assumption analysis and value ladenness, right? Because we will see that in assumption analysis has some tradition, but has not explicitly tackled what are the elements that make us take the assumptions. So I feel very comfortable with this framework. This is the framework that I'm pointing here, this hierarchy in learning and science and science production as well. We have it here. We have 3 levels: the learning level, the meta-learning, and the epistemic learning. So we could also call, this has been theorized from the scientific point of view, we could call this first-order science, second-order science, and third-order science. So what is interesting here is the relationship between the 3 levels. So the learning level could be defined, or the first-order science, as the way in which usually science has been made, traditionally, in the sense of assuming that there are no values. We have an external world, we are analyzing science. We are analyzing the external world, but we are not reflexive. We don't interrogate ourselves about the assumptions and the values. In the second level, meta-learning, there is an interrogation about what are the values, what are the assumptions, and how the assumptions are conditioned, are affected by some of the values. Here, I will center my talk. I'm centering my talk in this second level, in the meta-learning or second-order science. We have a third-order science that has to do, or epistemic learning that has to do with worldviews, right? So what is the worldview that we have? So those that belong to the Western society or belong to the academia have a worldview that has to do with rationalism, right? Those that belong to traditional knowledge that have other worldviews that affect the way in which they do meta-learning and the more practical approach to learning that is the first level. I think that the different knowledge systems, as we have discussed several times with Melody, have different interpretations of this pyramid, right? The challenge is to make these pyramids compatible, to make these pyramids dialogue one to the other, right? And assumption analysis is very important. Okay, now I want to briefly mention 3 works. So this is, I remember this approach of the pyramid of the hierarchical learning levels. It's where I center my talk and my research currently in the second level. So these 3 works, I could have chosen others, but I think these 3 ones are important for me, have been informative for understanding assumption analysis and the presence of assumptions when doing research. So the first one is an article published in 2000 by Thiller and colleagues, in which it's a very, I come from the coastal management perspective. So it's a first paper that in the field of coastal management questioned about assumptions and values, mainly assumptions present in models for making decisions about coastal management in the US and worldwide, right? Basically, the paper examines how all the models and all the tools for coastal management, mainly produced here in the US, which has been also always at the cutting edge of modeling coastal systems, were considering geologic and oceanographic principles and assumptions. And the conclusions is that they were very weakly considering the processes that were already known. The second work is a work of Mario Giampietro and Andrea Saltelli that has a very provocative title, Footprints to Nowhere, that it's a very strong critique of the ecological footprint tool for calculating the impact of humans in the Earth. And basically, Mario Giampietro and Andrea Saltelli, what they do is they dig into the assumptions of the model, and they understand all the incoherences that are present, and the impossibility of providing, again, what I was explaining, of providing a unique number, a unique response for such that really cover all the different processes, dimensions, logics, and units and narratives that that pretend to be included into the ecological footprint indicator. The third one is an article published in Nature in June 2020, and we have to remember 3 months after the pandemic started, in which I would say a group of the most relevant critiques of modeling write a paper in which provide 5 recommendations to society to ask for the quality in modeling that society deserves. So experts on the shortcomings of models are recommending society what are the questions that society should ask for when being represented by or accepting to have science as a rule for what they are doing. One very relevant conclusion of this paper is that it literally says at the end, modeling is a social activity, cannot be left just to the scientist. Modeling should be done by the whole society. So these are 3 very important, as I said, very important articles that affect or help me a lot in understanding the shortcomings of science and the perspective of assumption analysis in science. The thing is that this work has not tackled a very important question, that is, what is the values that are behind the assumptions that we are making. For that, there is another very interesting work. It's the work of Klopogli and colleagues that was published in 2011 that tried to classify assumptions in 4 different types. Assumptions for doing science and for doing modeling. So the first one is general epistemic, that kind of reflect the choice in the production of knowledge that the scientists make. The second one is disciplinary bound, so it has to do with the training in a specific discipline of the analyst. The third one is sociopolitical. It has to do with the values and ideology of the person that is making the assumption. And the fourth one is practical. So when there is shortcomings in the resources, we are making assumptions. When we don't have time, or we don't have data, or we don't have people, we make assumptions as well. So I think this classification of the type of assumptions, I think it's very useful. And we use that in our group to do the work. Okay, that being said, now what I'm gonna briefly present is 3 cases, 3 instances of assumption analysis, of value-ladenness of assumption analysis that we have done in our team, in the Interface team in Barcelona, in the Universitat Autònoma de Barcelona. Basically, what I will present is a limited part of the work of 3 PhD students that work with us. The first one is about fisheries policies in Chile. The second one is climate adaptation plans in Barcelona. And the third one is a beach management tool in Catalonia. You will see that there is a differential approach to the analysis of assumptions. The third one is the more systematic, and is the one that I will propose. I will open up to you, see what you think, and the possibilities it has for further studies. So the first case is the work of Gino Bailey. Gino Bailey is this person here. Is a PhD student that will defend his PhD thesis in 10 days. And he has worked studying the artisanal fisheries in Chile, in two localities, Orcón y Ventanas, located at the coast of Chile. What he has, has done a fantastic work analyzing different things, but what I will present here is the analysis of three specific assumptions. So the context here is that, in the 80s, as a response to the scarcity of resources in fisheries, new policies were established, new sustainable policies or sustainable development policies were established in many countries. Chile was one of them. So these policies have specific effects on artisanal communities, right? The context we detected in our study, this, the phenomenon that has described in the literature of the rollback and rollout of the state when creating policies and organizing governance, that is present in the fisheries. Mainly, the process that we found in Chile is the rollout process, in which there is a control and an establishment of a management system that controls extraction of resources, but is profit motivated and has differential impact on the different types of stakeholders. So artisanal fisheries see their activity limited, but semi-industrial or industrial fishermen are benefited for this type of policies. So we identified three assumptions, and since we understood that the logic of the functioning of the artisanal fisheries was outside what we could call the development model in Chile, we used the approach to community economies of Gibson and Graham to try to understand economic practices and assets that would be invisible to the dominant development model, right? And we use the description of these practices and assets as a way to contrast the assumptions that we have detected and identified in the policies and the instruments. This work part of it has been already published in Ecological Economics. So the first assumption that we found is this. The artisanal fisherman is extractive and not trustworthy. He is rational and calculating in his capture procedures. He must organize his company as a fleet owner and must use technological devices such as the GPS to be more efficient in the capture. So this is something that is at the root of the plans and instruments that were developed in that period and obviously affected the subsequent practice that they carried out. We call we understand that this is a socio-political assumption because it has to do with the values of the analysts that assume that. And basically what we see empirically is that traditional activity limits itself based on ecological cycles and rhythms, in contrast to semi-industrial fishing that has, through technology, the purpose of having a more maximizing extraction in resources. The fisherman works in a supportive and generous manner with his peers and with the environment. This is something that we also detected empirically. One point that I want to put on the table here is that I'm conscious, I try not to romanticize artisanal activities, but this is empirical data that we found. I'm not saying that artisanal fisheries or the fishermen were doing everything well. What I'm saying is that many of the things that they were doing are not considered in the policies that were established afterwards. The second assumption is that in artisanal fishing, the catch is limited to one or two species. We see this assumption because from a certain moment, the fishermen could only have permit to fish one or two types of fish, not have a diversity of possible targets. What we found, and we call this general epistemic assumption, because this assumption has to do with the approach, how we conceptualize what a fishery is. the original practice of fishermen is based on multiple and different species, and there are several examples. The third assumption is that fishing practice does not imply mobility through the ocean beyond the administratively designed regions. There are no ecological and cultural meanings linked to its movement practice. So why we detected this assumption? Because from a certain moment, fishermen were limited in the areas in which they could fish. They had assigned specific areas and could not move and could not go to other places to fish. What we found, and this is another general epistemic assumption, has to do with the way in which knowledge is conceptualized. Artisanal fishermen have historically moved along the coast according to the availability of resources and reproductive cycle of the species. So ecological reasons were behind this nomadic behavior that now they are prohibited to do that. Okay, so those three assumptions, as I said, we are using the framework of Gibson and Graham for community economies. They proposed the metaphor of the iceberg for analyzing invisible economic practices and assets. So what I tried to do is for each one of the assumptions, try to map in this iceberg the assets that were visible and those that were invisible. So for the first assumption, obviously, so what we have in the emerge part is something that is visible, and it's in accordance with the development framework or the model for growth. So we have certainly some market exchange in the activity of the fishermen. We also have some adaptation and some use of technology. We certainly have that. In a more obscure way, we have some practices, some of which are not legal, that are also there. For example, theft, collusion, and black market. And we also have more direct sales from home, which I would put it in the middle. So then we have a bunch of assets and practices and activities that really question the assumption that is made in regards to, first, the unsolidarity of the fishermen. We see that they had a very strong collective approach to fishing. They generate resources for all. They understand. So they work collectively, and they also are very efficient in the use of the resources. For example, they reuse fishing gears, boats, and on fishing material. So that's something that is very clear. So for the second assumption, we see that although multi-species fishing is prohibited, they are still doing it in different ways, right? So this is not, something that they used to do, it is something that they still do, although it's not visible for the development framework. So regarding the mobility along the coast, certainly now they have adapted and they fish in management areas, in areas where they are asked to fish. But still, they also fish outside permitted areas, and they also apply practices that include fishing by identification of fish populations. So they are able to track and to understand natural cycles in their practice. Okay, now I'm gonna move to the second example. This is the work of Ana Marin that will defend her PhD thesis in less than 2 months. She has analyzed, we are moving from Chile to the Delta del Llobregat, the area right below, right next to Barcelona. It's a very interesting area. It's the area where the Barcelona airport is located. It's a wetland that has an agrarian park and has a lot of infrastructure, so a lot of tension in the work of in the activity of the different stakeholders. So basically, Anna has studied the knowledge that is being produced for adapting to climate change. And we will see that has a very particular definition of knowledge and uncertainty. So what I will present is a very limited part of what she has done that has to do with assumption of with analysis of specific assumptions. So the first thing that I have to mention is that the work of Anna is based on a concept of uncertainty that is expanded. So what would be considered uncertainty mostly in traditional science? It would be considered the response to this question. Is it scientifically robust? The work, well, I mean, there's a long body of studies working on uncertainty in post-normal science, but this is a kind of a synthesis of how now uncertainty is conceptualized in complex systems. So we see here, on the one hand, 3 dimensions: the context, the process, and substantive. This is the dimension usually tackled in science. And we also see 3 phases: the phases of framing the problem, producing knowledge, and communicating the knowledge. So we have 9 different questions that tackle different elements, different dimensions of uncertainty. What I will present is this. The answer to the question of the problem framing and that belongs to science. So what is that we have to assess? This question is linked to some assumptions and some value ladenness, as we have already commented. So Anna worked on it, and it has relevance for defining what are the boundaries of what we are studying, how we represent the system, and what is vulnerability for us, right? So, you will see more specific examples of this with the assumptions that we have. I'm going to present 2 of them. So, the first assumption when framing the research, when the knowledge that is included in adaptation plans, is how we understand climate change in the plan. And the first thing that we find is the climate risk occurrence is expected to begin in 2050. This is what is at the root of the local adaptation plan. And why is it so? Is it so because it's just considering a part of the effects of climate change, that is sea level rise, right? So flooding in the Delta del Llobregat, the practical conceptualization of climate change is the increase in sea level rise. What is the big problem here? The problem is that there is another very important factor related to climate change that is not included in the plan. That is the effect of storms, the increasing effect of extreme events, which has certainly been demonstrated to be part of the climate change effect, and the synergy between sea level rise and storms, right? So particularly in the area, we have eastern storms that have repeatedly created a lot of problems and a lot of flooding. So again, we consider that this is a general epistemic assumption because it approaches climate change in a non-systemic way. So from the point of view of system science, it should be the combination of sea level rise plus the coastal storms should be included. It's a reductionistic approach. The second assumption is that each territorial entity, land use, behaves with homogeneity under a specific climate risk. So here, basically, the main consequence of that is that, you should understand, we have a territory, we have some maps, we have some analysis of the maps, and we have land uses. So land uses are treated all the same in the analysis. So we have an agrarian park, and the plan assumes that the effects that the farmers will suffer will be the same for the whole area, right? We understand that this is a practical assumption. The lack of resources is what makes the developers of the plan to make this assumption. So here we have a map of the area, the Emi-Delta South, the South Emi-Delta of the Llobregat Delta, and this is a map that was developed right after we had a very significant storm, Gloria storm, in January 2020, that provoked a flooding that was something not previously recorded. So here we can check these two assumptions. The first one that has to do with neglecting the effect of coastal storms. So here we have in the graph here from 1990, in the last 30, we have for 30 years a register or what is called, like technically, this is the monthly maximum significant wave height, that it's an approximation to the energy of the storms. So how are storms evolving through time? What we will see is that the four highest values registered took place since 2010, and the three highest since 2017. So we are clearly seeing there is an increase in the energy of the sea and the effect of the storms that is not considered in the adaptation plan. The second thing, the second assumption is this one. This is all this area. So this is the airport of Barcelona. All this area is the agrarian park. And you see in turquoise colors, you see the areas that were flooded after that particular storm. So you see here, there's a lot of complexity on why some parcels were flooded and why some were not. Part has to do with proximity to the sea, but also has to do with the way in which the farmers are organized. A very important factor, how close they are to the airport, because the airport, you should think in this situation, we have an airport located in a wetland, and what the airport wants is to get rid of the water. So how the airport gets rid of the water? It has some pumps that help to impose the water to the sea and to the sides. So totally changing the natural dynamics of the delta. The water that comes to this side comes to the agrarian park and generates flooding in this area. Obviously, none of this is included in the adaptation plan. Well, the third case, now we're going to move to the beach management tool that was developed by another student that is already a postdoc student, Brianna Bombana. What she basically did in her PhD thesis was correcting me, right? So I did my PhD and I developed a system of integral quality indicators for monitoring beach systems in the Mediterranean. It was an exercise very much, mostly based on scientific knowledge, all right? So what Brianna did was try to contextualize that and try to co-produce knowledge with the actors to improve and make the system more operational. Basically, one of the exercises that she did was to assess the assumptions present in the set of indexes and in the knowledge on coastal management. So she applied that, and basically now I want you to remember the categories, because now I'm going to present the part of the work that is more systematic. You remember we have already discussed about this value-ladenness, these categories for assumption: general epistemic, disciplinary-based epistemic, socio-political, and practical. So basically, she adopted a set of criteria for each one of these categories to make a systematic analysis of assumptions. So for example, for general epistemic, there were two criteria: plausibility. How close is the assumption from reality? Another criteria is choice space. Could other assumptions be made instead of the one that was considered? For disciplinary-based epistemic, is there agreement among peers about these assumptions? So if we think about coastal engineers or coastal specialists in physical processes, would they all agree in the assumptions that we are making? Then there is the socio-political part in which it is assessed the analyst objectivity. I must confess that there are other better criteria for this element. For example, we could have included here agreement among stakeholders. Would have been interesting to put this criteria here. And the last one, for practical, influence of resource limitations. So for analyzing the assumptions, what we did is, or what Brianna did, she came up with a list of 25 assumptions. From these 25 assumptions, she produced a short list of 10, and then we organized a co-production exercise through 5 different focus groups to assess these 10 assumptions, and each focus group mixed specialists, scientists, like stakeholders, politicians, practitioners. And now what I'm going to do, well, I'm going to present how these criteria that I just listed were organized. So let me try to understand this well, to explain this well. So here we have the criteria, right, that we have mentioned: plausibility, choice space, disagreement among peers, analyst objectivity, and influence, and resource limitation, sorry. Those are the criteria that were chosen. And we have here like a table to try to assess them. And we basically, when we had the focus group, we had the assumptions, we discussed the wording of the assumptions with the people, then we had a debate, and finally, by consensus, we assessed each one of the assumptions. What we have here as well is a very important element. So with this criteria, we can assess what is called the quality of the assumption. Is it strong or is it weak? But we also have to know what is the influence of this assumption on the overall result, right? So is this assumption very important for the result? And these two elements, the weakness and the influence, is what help us to make a decision about the importance or not of having the assumption in. Well, that being said, I explained what is called the pedigree matrix, right? With this criteria and these qualifications. Where it comes from? It comes from what is called the NUSAP approach to uncertainty. And what is that? Basically, this is a proposal of postnormal science that what tries to do is to expand, it's one of the ways to expand the consideration of uncertainty. Uncertainty cannot be treated just statistically. It's not just about doing better statistics and having better data. It has to do also with qualitatively analyzing the process by which we produce the numerical, the numbers, right? So we analyze how we have arrived to a certain result, and that is part of the uncertainty analysis as well. Well, that being said, now I'm gonna briefly present two assumptions and the scores. So the first assumption I wanna present is this: beach user satisfaction is the main objective of beach socio-ecological system studies in the Mediterranean. So what's the reality? It was discussed in our focus group that this assumption leads to poor understanding and valuation of habitats, disregard of pollution, disruption of natural processes, neglect of coastal development trends, and exclusion of local users and fishermen. What we have here is the scores that the focus group came up with after the discussion. What we see here is that there is the disagreement among peers is very high, so the higher the number, the higher the weakness, right? And also that it's very socio-politically affected, right? The analyst objectivity also was questioned. And we have that it has very important influence on the global outcomes. The next assumption is a very technical one, and I'm gonna explain briefly what I mean by that. The way in which coastal protection, what is coastal protection? Coastal protection is the capacity of the beach to absorb wave energy and protect human infrastructure that is behind. So how is that measured, or how has been traditionally measured? That has been measured through different approaches, but a very important one that was adopted here is through a US-created model, is the S-Beach. I don't know if you are familiar with it, that basically considers three things. The first one is what is the width of the beach that we have? The second one is what is the strength of the storm that is coming? And the third one is what is the minimum of the beach that we need to absorb the energy of that storm. With these three variables, it creates a model. This model was created here in the US and has been applied worldwide and in Catalonia and Barcelona as well. So what we saw when we analyzed this assumption, we saw that it is a very reductionistic approach in the sense that considers just one dimension, the dimension not so just the cross-shore dimension, but does not consider the volume, for example, of the beach. The part of the beach that has dunes, the height of the emerged part of the beach is not included, and also beach rotation, how the beach moves during the storm to defend. Well, you know that in a pocket beach, the sediments go from one side to the other. That's a very relevant element to define protection. Well, this is a very technical one. A very important, a relevant element here is that this, and this is known, this process, the use of this indicator requires a very sophisticated calibration process. This calibration process, because obviously measuring the dynamics in a beach in the US is very different from Catalonia. This process has not been carried out in Barcelona, and the ones that are applying the method know that, right? So the evaluation, so we see here that the two elements that were included, the plausibility, so the coherence between the assumption and reality was not high, was not low, sorry, and then that there was a clear influence of resource limitations. We had the confession of one technician that told us that this model was being applied without a calibration process because it was very resource consuming to apply the calibration process. Okay, we have here the list of the 10 assumptions. I will go briefly through it, but the important thing here is that you understand, so we identify the assumptions, we have the criteria, we have the average for each assumption, and we have the influence on the global outcome. At this point, I want to make a confession. I'm not always convinced. I see some weaknesses in the criteria. So I think that the criteria could be improved. But that's something that I think it's useful. I mean, I think that using I like this approach because it provides a structured approach to analyzing value-ladenness in assumptions. I think it's very interesting. The criteria could be improved, others could be included, but there is room for doing so. So I think it's still, this approach has limitations. It can be useful. Now, here, we are representing, so the 10 assumptions that we considered are here, and we have here, so we can plot in this axis the average pedigree score, so the average of all the criteria for each one of the assumptions, and in this axis we can plot the influence on global outcomes. This is very relevant because it helps us to establish a space of risky assumptions. What we have here is the most critical assumptions, the assumptions that are making our model weak. So we can discuss them and we can we can substitute them for others if needed. Well, that being said, now I'm going to proceed with the concluding remarks very briefly. Well, the first one is that the assumptions that we detected and that we studied, that it does not mean that are all the possible assumptions, harm the affected traditional communities and ecological systems. I understand that we have different knowledge systems and we cannot provide a unified answer, and at some point we have to leave the systems work alone, so independently. So science works in its way, like traditional knowledge production works in another way, but we have to be able to establish some bridges, to have some kind of coherent framework to manage and to do the governance of the areas. The problem for me is when we, in one system, such as the scientific one, we have explicit assumptions that deny the logic and the functioning of the other knowledge system. So for me, this is the problem, right? And we have detected, I think the case of Chile is very clear. Some of the assumptions of the policies that we analyze explicitly deny the functioning of the traditional or the artisanal fisheries, right? The second conclusion is that there is a strong gap between scientific and local knowledge. We have not detected a very big gap between different disciplines. It's not that we see a lot of conflict in between the disciplines, but the real conflict is between scientific and local knowledge. So, I can understand that. There are two very different approaches to knowledge production. The problem is that we are detecting this gap in documents or in dimensions that belong to different knowledge systems. So this is not a paper or a scientific article where we are finding this. This is in a policy or in an adaptation management, adaptation plan. So it has real, very important consequences. The third element that I would like to discuss is a proposal. We think that with co-production, we can rework the assumptions. So we can change the assumptions and produce different type of knowledge. And a very important element as well, I have described some practical assumptions to knowledge production. So those assumptions that are made because I don't have resources to do other types of knowledge. The proposal here is to use co-production to compensate the resource limitation in knowledge production. It can be much more efficient. And with that, I would like to finish. Thank you.
Say we will take questions now, so I'm not on the mic, and I may start us off. Oh, it's on, good. Thank you, Eduard. I have a question for you. Really appreciate your working through the gaps that are not necessarily a scientific paper gap. They are actually a governance gap of when we're trying to put these knowledge systems together and finding bridges and really looking at the assumptions we're making when we write these policies. One that you mentioned was an assumption that the climate risks is expected to begin in 2050. It was one for your climate adaptation. I wondered, where is that an assumption made? How is that created in the governance? Where do you see that assumption come up, that are saying if we don't reach it by 2050, we will have this risk? Or where do you see that kind of risk assessment show up?
Thank you. Well, what we saw is that the effects of, so the framing of sea level rise effects, the first moment in which they were considered was 2050. Before that, they were considered like neglectable. So that's what is included in the plan.
That's simple.
Thanks, Edward. I have a related question. Do I need the microphone?
We're all good till 2050.
Thank you. Hi, I'm Chris Nedden, and thank you for the presentation. I have a similar question to Melody's because it occurs to me, right, that the assumptions are coming from somewhere or someone. And so I wondered if, because I'm thinking in Chile, that sounded just straight out of the University of Chicago Economics Department, which were the guys who sort of took over development planning in Chile during the Pinochet regime. So I wonder if you could just comment on that. I mean, how do you account then for how those assumptions, and maybe some of them are traceable back to papers. So I know in a lot of fisheries work, you can go back, right, 50, 60 years and still see, even though now there's been a whole bunch of research showing that those assumptions are not valid or are problematic, they still seem to be getting repeated. So does that make sense?
Yeah, absolutely. It makes a lot of sense. Well, what we did, and this is a work that was done by Gino Bailey, is analyze the documents that are in place and the norms that we have today in place. So, for example, for the case of the mobility, the assumption that artisanal fisheries takes place in a static way, the assumption, this is established because, basically fishermen cannot go to fish. I mean, they are asked to develop their activity, but they are not allowed to go up to a certain limit. That is what they did, like traditionally. How far back up to where we can trace that? Well, I have not done that exercise, but yeah, I mean, we are one of the things that we are seeing in the case of Chile is that it is a very particular case, and we see how the policy developed from the 50s and 60s, and we see like the dictatorship like applying some time of management measures, and that trying to change somehow in the mid of the 80s with the new current of sustainability, but also like always kind of with the main value of maximizing profit. So it goes. I mean, the Chicago School of Economics can be there, but we don't like trace that. Nope.
Any other questions? No. With that, one more. Let me see.
I'm very interested in what you were talking about like climate change being a like political situation versus scientific. So in light of us like still needing scientific models and still needing modeling, how do you think we should go about like knowing that there are so many assumptions made, or what do you think?
Well, I think this is a very important point. Making assumptions is not something wrong. Making assumptions is part of the scientific process. And as Saltelli and colleagues said in the paper they published in Nature, it's not about avoiding modeling, it's not about making apolitical models, it's about disclosure. It's about putting on the table what are the assumptions and under which conditions the process of science is useful for society. The problem is that when there is if we don't make a disclosure, if we don't disclose the assumptions, at some point we make wrong interpretations of the results of modeling and science. That's the problem.
Thank you again, Eduard. This is, that's exactly it. It's questioning our science systems constantly is part of the responsibility of doing good science, especially when now this science is part of our potential, how we manage our global future. So thank you again for your being here, for your talk this evening, and we will be connecting many, many times in the next few years. So thank you again.
Thank you.
Thanks for being here.